What's up guys, Onmaths here, and today we're looking at volume and surface area. Now, I have chosen three quite tricky questions deliberately for this video. So if you're kind of new to volume and surface area, then we do have other videos and resources on the site onmaths.com to help you out. But I've decided kind of let's have a look at the more challenging questions. Mainly the second and third question today. So if this kind of scares you off the topic a little bit, know that these are the very hardest questions you'll get on the foundation paper. Okay, so with this first question, we are told that a cube has a surface area of 294. So if you have a think about what a cube is made up of squares. How many squares is it made up of? Well, how many faces does a cube have? 6. Okay, I've not drawn that cube very well. It looks more like a cuboid. But each of the squares all have the same area, and there's 6 of them. Okay, so if I don't label the area as a big A, then all of the squares, so the 3 that we see and the 3 round the back, just like sides of a dice, right, or a die, all have the same area. So all we need to do is we need to divide the surface area, which is the area of all 6 of them. We just need to divide that by 6 to find the area of one of the squares. Okay, so we're going to start off by doing 294 divided by 6. So the area, and we're going to just show the examiner what we're working out, area of one square. Okay, to do this we can just use the bus stop method. So, 6 goes on the outside, and 294. 6 into 2 don't go, 6 is into 29. Well, 6 times 4 is 24, so that would be 4, and that would leave, 5 left over, and 6 is into 54, going 9, so that's going to be 49. And we could put units, centimetres squared. Okay, so to work out the volume of a cube is just the length cubed, right? So it's just the length times the length times the length. Okay, we don't need to call them width, base, or anything, because it's just the 3 sides of the cube times together. And in a cube, all of the sides are the same. So we need to find the length. So we're going to find the length now. And to do that, all we need to do is just square root the area. So the length of the cube is 7 centimeters, and so to work out the volume, we're just going to cube that. We're going to times it by itself 3 times. So 7 times 7 is 49, which we know, and then we need to do that 49 times another 7, and we can do that with the column method. So 9 times 7 is 63, and 7 times 4 is 28, plus the 6 is 34. So the answer would be 343 centimeters cubed. As I said, we're not picking particularly easy questions today, and this was on an uncalculator. That's why I've shown kind of all my working out. Okay, as you can see from the question number, this next question from AQA is quite near the end of the exam, and it looks really complicated, but again, when you break these questions down, they're not as complicated as they look. So we're given a hemisphere. A hemisphere is basically half a sphere, and we're given the formula for a volume of just a sphere. So we're going to first of all work out the volume of this hemisphere. Okay, so to work out the volume, we find out the volume of the full sphere, which is given to us, the equation, but we need to halve it because it's half a sphere. Okay, we're told that the radius is 30, so we're going to put that into the equation. And all we're going to do is just type that into our calculator. So I'll press the fraction button, 4/3. And we do 4/3 times pi times 30 to the power of 3, 30 cubed, times half, or times 0.5, and you get the answer of 56,548 14.66776. Always try and write down as much as you can so that it keeps the accuracy up. Only ever round your answer. So now we know the volume of this hemisphere, we've kind of got to work out what the rest of the question's asking. It's saying that sand's going to fill that container at the rate of 4,000 centimetres cubed per minute. So the next thing we need to do is work out how much is filled after 1 minute. So after 1 minute, we know that 4,000 centimetres cubed is filled. Okay, and we've got to find out, well, okay, how long will it take to complete or to fill less? Oh, hang on, what's it say? Does it take less than a quarter of an hour to fill the container? So we've got to see how long it takes to fill the whole container. So we know the full container is 56,548.66776, and all we need to do is divide that by the amount of that it does in a minute, and see how many minutes it will take to fill the container. So this is to fill the container. Okay, so it's still on my calculator, and I can just type divided by 4,000, and it says that the answer is 14.13716 blah blah blah. Okay, that's saying that it takes roughly 14 minutes, just over 14 minutes, to fill the container. And it says, does it take less than a quarter of an hour? Well, a quarter of an hour is 15 minutes. So the answer is yes. Because 14.1 minutes or whatever, roughly 14 minutes is less than 15. So I could even show that here, saying that that is less than 15 minutes. And make it really clear that I've understood that 14 is less than 15 minutes, therefore yes it does. So a really tricky question with all the bits you have to do, but given the fact they've given you the equation of the volume of a sphere, hemisphere, you just got to know that that's half a sphere, so we've got that times a half at the end because we need to halve it. And just understanding what rate means, just rate is the amount that it fills per minute, so it's every minute it's going to fill up 4,000, so therefore to find out how long it takes to fill up the whole thing, you put the total volume and divide it by how much it fills in 1 minute, and that will tell you how many minutes it takes to fill the whole thing. Not the easiest of questions, but we're going to finish with OCR's offering. Now, I had to get this from the practice paper that they released before the first exams of the new spec. Just that this was a really nice question, just to illustrate kind of all the bits that you need to learn with volume. So we've got a cylinder here, and we're filling it with balls, and it's basically saying how much free space is there. And so the balls are going in the cylinder. There's 4 of them, so 1, 2, 3, 4. They go in the cylinder there. They're supposed to be equal sized. And so all we need to do is work out the volume of the cylinder, take away the volume of each of the balls, because the balls will be taking up that amount of space, and that will give us the unused space, which is asking us in the question. So we're going to first of all work out the volume of the cylinder. Now, a cylinder is the same as a prism. It's just a circle-based prism. So to work out the volume, all you need to do is work out the area of the circle and times it by, in this case, the height. So area of the circle is pi r squared, and we're going to times it by the height of the cylinder, okay, or the length, depending on what you want to call it. So the diameter of this circle is 6. Therefore, the radius is going to be half that, which is going to be 3. So it's going to be pi times 3 squared times the height, which it says is 24. Is this calculated? Yep, it's a calculated question. OCR paper 1 is calculator. So I'm just going to type this in the calculator, and it gives me 678.58403132. Blah blah blah. Okay, And now we need to work out the volume of one of the spheres. So one sphere. So the volume is going to be, and it gives us the formula down here. It's the same one as we used the one on the last question. So it's 4/3 times pi times, and we're just going to have a look and see what the diameter. So it says the diameter of each ball is 6 centimeters. Therefore, the radius is going to be half that, which is going to be 3. So 3 cubed. Let's type that in. So 4/3 times pi times 3 cubed, and that gives the answer of 113.0973 blah blah blah. And then we want to work out the volume of all four spheres. So let's just check. It says there's 4 spheres, right? So 4 solid balls. So 4 spheres is just the volume is going to be the thing we've just worked out, blah blah blah, times 4. And I've still got it in the calculator, so all I need to do is times 4. Which is 452.3893421. And so I want to do the volume of the cylinder, take away the volume of the 4 spheres, so unused space. Just show the examiner what it is that I'm working out. So the volume is going to be the 678.58 blah blah blah. Take away 452.38 blah blah blah. Now I've still got the 452 in my calculator, so what I'm going to do is type in 678.58403132. Take away, and what you do on the Casio calculators and most other calculators is you press the answer button, and it will use the last answer you used on the calculator. Press equals, and you get 226.19467 blah blah blah. Next we need to figure out what we're going to round it to, and I think 3 significant figures would be more than enough, which would be like that. So just the first 3 numbers, so 226. You could have left it in terms of pi, and basically for each of these just have them in terms of pi and then take them away, and your answer would be in terms of pi. And since it doesn't ask you to round it or anything in the question, that would be more than acceptable. So much trickier video than usual today, but as we get towards the end of these series, the questions will just get harder and harder. And mainly we're on grade 5 territory now with these videos, so hopefully you're following along. If you've stuck on any of this stuff, just check out our website. We've got loads of easier videos on volume and surface area to help you out. I hope you enjoyed this video. I hope you found it useful. If you did, please click like. Keep your comments coming in about ideas you want us to do after we finish summer school. If you want to see more from us, we release videos every single weekday, Monday to Friday at 9 o'clock in the morning. Just click subscribe and the bell icon to make sure you're up to date with them. If you haven't already, which I'm sure you have, check out our website onmaths.com. There'll be a magical card that appears at the top of the screen to take you straight there. The website's full of absolutely free maths resources to help you with your maths. Otherwise, thank you very much, and I'll see you in the next video.